outset, I would like to thank Professor Dhar and SHM. So I would now begin the session with first asking the panel. So let me pass on the first two, madam.
So today's topic is quantum and 5G in AI. What is qubit? Qubit is a quantum counter for classical bits 0 and 1. So our classical computer only knows 0 and 1 bits, and the quantum counterpart of those bits are qubits. And the qubits, the unique property of a qubits is that it can stay in the superposition of these 0 and 1. And before measurement, you cannot say whether this is 0 or this is 1.
Honestly, 5G allows the data to be at the edge, and AI can work on that, because every day we are seeing that my edge devices are now getting higher computation, higher capacity to perform the AI at that site. But in order to make the work more efficient, you need a data to be there, and 5G allows to do that. So that's what I see AI for 5G for AI. So I think we start with that quantum threat. How do we address that? And then we see where we can utilize the quantum. And obviously there is a notion that there will be immense possibility when quantum and AI kind of gets combined. Thank you.
It is on 4th of March 2024, just a few days ago, Google announced a prize money of $5 million in order to ask the people to find out what is the application of quantum computer in societal usage. And for that they have announced 23 prizes. And why it is important is we have a tool, we have a very powerful tool, but how can that be used for humanity is still a question. So with this, I would want to pass it on to the next speaker and hear their thoughts. Thank you.
Quantum 5G for AI technology pathway. I think it is a very relevant topic in today's technology context. Now next question comes, what is the relationship between the 5G and AI? How does 5G use the potential of AI, or what AI will be, how, in which way AI will be integrated on the 5G? This is the question we have to think about. So here poses the technology challenges. It has to cater the very high speed communication services and also with a low latency. The quantum computing will be faster communication, that is, it should be complemented the AI use on the 5G and 6G. That's all. Thank you.
I see a very young crowd in the audience, so instead of again speaking about quantum, 5G and things which you guys have already heard now, I want to just open the floor that what do you guys want to speak about? I mean, what do you think that we should be discussing? Anyone with a question, technical, non-technical?
Good morning, sir. So I have so many questions. From one of them is that in what ways can 5G's low latency connectivity enhance the power of AI applications and all?
See, how I see 5G, so 5G right now, at least in India, is going to roll out in a much more heavier manner. And when we talk about lower latency, this is going to be a challenge, specifically in a country like India, right? Because our routings are very much unoptimized as of yet. So I will just pass on to others.
So latency, there is a communication latency, that is, you have to process and pass on the decision. If the distance between the end user and the computational processor are higher, the latency will be increased. So if you compute the thing near to your device, then communication latency will be reduced. That is the policy for that.
So this open source will fire against all the existing LLMs in the world and give you back the response. With that, actually, you can augment your tiny LLM in your organization.
If you look at some of these autonomous car or connected car kind of a thing which are happening, right, where you absolutely need a low latency communication.
A qubit, Q means Q and U, the two starting words of quantum. A qubit is like a coin which has two sides, head and tail, maybe 0 and 1 we can say, and you place the coin on the edge. So if you place the coin on the edge, then you have simultaneously the two states. And like this, if when you have say 2-bit computer with quantum computing facility, then you have all the 4 states simultaneously.
So there are several, as I mentioned earlier, that there are several algorithms, quantum algorithms. One is Shor algorithm, which proved that some NP problem in classical domain can be converted in P in polynomial time algorithm in quantum domain. Similarly, there is another problem that is called Doyle's algorithm. What Doyle's algorithm says? Doyle's algorithm says that if I am giving you one Boolean function which will be either balanced or constant. What is constant function and what is balanced function? In Boolean function is the input will be n bit patterns and output will be just 1 bit, either 0 or 1. So what is constant function? Constant function for all input n bit patterns. So how many n bits patterns will be available so that is 2 to the power n. So 2 to the power n many patterns you can get if you consider n bit string.
One particular signal giving element can have 3 states simultaneously. And there are qubits also that are coming up. So, but the only problem here is that when you generate that signal, that should be in a kind of an environment that there is no other external disturbance. And here the external disturbance is not about dust, moisture or temperature, it's about any other signal in whatever form interfering that particular state of the circuit.
We are trying to see right now how quantum computing and 5G can be used for AI. This is the place where AI is being used for correcting errors in quantum computing.
Many operators would not invite this sort of problem. What they did, they offline trained the model through quantum machine learning. Then these data will be fed into the live AI model streaming. This way they have reduced or controlled the error connectivity, which is a very useful aspect of communication or 5G, 6G network using the quantum machine learning.
Okay, so from my practical experience, quantum computers, right, like how we see our laptops and desktops and probably servers, I think it's pretty near, right? So we already have cases in China where a similar university like Tijuana University have already deployed quantum computers which are around $50,000 for the students. And this year, so we basically are working with few of the OEMs which are part of building those kind of systems. So they are targeting it within a range of around $5,000 technically. So I think access to universities, research purpose, this especially in a country like India where we now have government backing and a lot of big programs coming in, I think within next 4 to 5 years, we should have those kind of capabilities, especially in the academic and research level.
Let me just put forward a question to you that what are the current projects that you think you are involved or you know about in this field, and what are the areas of application?
So I'll be very honest. I think I probably not don't say I was mentioning about that adoption of quantum in a business industry side, not necessarily there. But what the other side of it, I'm sure you probably have heard a term called quantum safe. Okay, well, that is around how we make the all the cryptographic assets safe from the quantum threat.
Okay, so I like to mention regarding our national quantum mission that our central government announced very recently. DST, Department of Science and Technology, they recently announced that mission. Actually, last year our government sanctioned 6,000 crores for this quantum mission.
Our organization deals with largely payment systems, and in payments, everything that moves around is encrypted.
My question was directed from a topic that came up towards the middle of the session. That is, quantum computing, as ma'am said, it is giving us a lot of errors in the current scenario. And to detect those errors, somewhere we are using AI technology for that, AI or ML. So, as Sir said, isn't this a reverse methodology or reverse workflow going on? Because AI itself right now is in a situation which is susceptible towards errors. And we do not have enough data set also to train it that which is an error and which is not. So I think this is an infinite loop going on, that one side AI doesn't know what is the true error, and the way it is detecting or which it is detecting, that is also producing error which is obviously not understood. So isn't this a unending methodology going on?
Can you reply this?
As I also mentioned, it is a bidirectional factor that is going on. So only hope is that with every pass of the cycle, the quality of the result will improve. That is the hope. And when we say that AI is giving us error, that is, the error is because of a reason which is different from why quantum computer is giving an error.
I thank all the panelists for their great insights, and lastly I also thank the organizers, Professor Dhar, NSHM and the Analytics Society for this interesting panel session. Thank you and good day. Thank you.